In April 1986, the Chernobyl nuclear power plant exploded. The blast released a deadly cloud of radioactive material across Europe. Forests were scorched, entire towns were evacuated, and the area surrounding the reactor, the infamous exclusion zone, was abandoned, left behind as a 30-kilometer wide ghost town frozen in time. It was one of the worst nuclear disasters in human history, and yet, something unexpected grew in the ruins. Inside the reactor's wreckage, where radiation levels remained dangerously high, scientists discovered something alive, not just surviving, but thriving. A strange black fungus was slowly spreading across the reactor's walls, feeding, not fleeing, from the radiation. Let's explore Chernobyl's radiation-eating fungi, a real-life organism that seems to turn death into energy. The discovery came in the early 2000s. Robots equipped with cameras were sent deep into Reactor 4, the most contaminated part of the plant. Scientists expected to find decay and corrosion. What they didn't expect was life. Clinging to the steel and concrete, they saw dark patches of growth, fuzzy, black, and alive. Samples were retrieved and analyzed. What they found stunned the scientific community. Several fungal species, Cladosporium sphaerospermum, Cryptococcus neoformans, and Wangiella dermatitidis, weren't just tolerating radiation, they were attracted to it. They grew faster and more robust the more radiation they were exposed to. This wasn't just radiation resistance, it was radiation harvesting. The key was melanin. Melanin is a pigment found in many organisms, including human skin. It protects us from UV radiation by absorbing it and converting it to harmless heat. But in these fungi, melanin was doing something even more extraordinary. It appeared to be acting like a biological solar panel, absorbing ionizing radiation and converting it into chemical energy that fueled growth. The process, known as radiosynthesis, is similar in concept to photosynthesis. But instead of using sunlight, these fungi are feeding on radiation, one of the deadliest forces in nature. It was as if evolution had found a way to turn poison into power. This discovery didn't just shake up our understanding of biology, it opened the door to some mind-bending possibilities. In medicine, researchers are now investigating how melanin and radiation-resistant fungi could be used to protect human cells. Imagine a melanin-based drug or cream that shields astronauts or cancer patients from radiation damage, or using fungal genes to engineer cells that can survive higher doses of radiation during cancer therapy. In nuclear cleanup, scientists are exploring how these fungi could help decontaminate radioactive sites. Planted in the soil around Chernobyl or Fukushima, these organisms might slowly draw in and trap radiation over time, acting as biological radiation sponges. And then there's space, where the potential becomes even more fascinating. In 2020, NASA and researchers on the International Space Station grew Cladosporium sphaerospermum aboard the station to see how it responded to cosmic radiation. The result? It not only survived, it thrived. The fungus grew faster than expected and even blocked some of the ambient radiation around it, suggesting it could act as a natural, self-replicating radiation shield. That's a big deal. Radiation is one of the greatest threats to deep space exploration. Prolonged exposure to cosmic rays can cause cancer, neurological damage, and genetic mutations. Traditional shielding, like lead or water tanks, is heavy and expensive to transport. But imagine this: a layer of radiation-absorbing fungi grown directly on a spacecraft, Mars habitat, or lunar base. Light, flexible, self-repairing, and alive. Astronauts wouldn't just rely on technology for protection, they'd be shielded by a living organism that evolved to thrive in environments far deadlier than space. Back on Earth, the discovery also shifts how we think about life's resilience. The fungi growing in Chernobyl weren't imported or engineered, they were already here. Earth life, adapting in real time to one of the harshest, most toxic environments we've ever created. While humans fled, these organisms moved in and made radiation their home. And that tells us something profound. Life isn't just tough, it's innovative. It doesn't always resist danger, sometimes it harnesses it. Could similar life exist elsewhere in the universe? Places we've long dismissed as uninhabitable, like the icy surface of Europa, the caves beneath Mars, or the atmosphere of Venus. If Earth can produce life that feeds on radiation, who's to say life beyond Earth hasn't done the same? Chernobyl's fungi might not just be survivors, they might be templates, proof that life can emerge and adapt even in the aftermath of catastrophe. Of course, there are still unanswered questions. We don't yet fully understand how radiosynthesis works on a molecular level. We don't know the limits of how much radiation these fungi can absorb, or whether we can safely engineer them for large-scale use. And introducing fungi into nuclear sites or space habitats comes with its own set of biosecurity concerns. But the implications are undeniable. What began as a disaster may now hold clues to surviving in the most extreme environments imaginable. In a world where nuclear threats and space colonization are no longer science fiction, these fungi might offer real solutions. They remind us that nature is full of surprises, and sometimes the answers to our biggest problems are already growing in the darkest corners of the earth. So next time you think of Chernobyl as a place of silence and decay, remember this: beneath the ruins, life didn't just survive, it adapted. And in that adaptation lies hope. Hope that even in humanity's worst mistakes, nature finds a way to not only endure, but evolve. Thanks for watching. Don't forget to subscribe for more stories from the edge of science, survival, and the secrets of life itself.